going to. Um, so, yeah, so basically we're primarily just trying to continue at this point to work towards the submission for Wednesday. Luckily, the submission there is anywhere on Earth time, so as long as it's Wednesday somewhere, out in the middle of the Pacific, they'll take it. So that is a bit extra time, but still not much. So the main things to work on now are just finishing up some of the baselines. We probably won't actually do baselines, I think, for all the different counties at the moment. Right now, I'm just finishing on getting them for the major metro cities, and then using, obviously, what we already have. So yeah, that's kind of the thing with that. Thanks to Aradhana and Pranjala for helping to get some of that done. Thanks to the other people who've been contributing too. I know we've been focused on this right now, but both Wendy and Maggie have been doing some good work on data we're going to integrate in like the kind of phase 2 stuff. So that's also good. So yeah, for today's thing, I'm going to show a basic kind of tutorial for how to actually use the transfer learning part with the notebook, just so everyone knows how to do it in the future, because we might be using that a lot. And then yeah, if there are any questions after that, then that's good. So let's see. So yeah, I posted this link to the channel. So as a couple of you who have already worked with this are familiar, basically everything is based on a configuration file here. So basically, if we want to do transfer learning now, we now include the weight path into the function that makes our configuration file. I think Pranjal has already kind of done some of this. And then, if there's a weight path, then there's just this if statement, and then the way the framework's configured, it will load the model from that at that weight path. Now, what if there are layers, though, we want to exclude from the model because they might have different dimensions? Or if there's new layers we want to exclusively fine-tune from scratch. So if there are layers we don't want to load, well, we just put them in excluded layers. So for instance here, since the models we're pre-training, at least with the wind and solar, might have different sequence output lengths, we're excluding that final linear layer. So it's just basically the name of the layer and then dot weight and then the name and dot bias. So now when this loads, it won't initialize the weights for this last linear layer, because if it did, it would cause a size mismatch. Okay. So that's just an extremely brief tutorial on those. I just wanted to show everyone that new functionality. I actually just added it to the main forecasting repo yesterday. So this is now, you can now use this for any type of transfer learning. Does anyone have any questions on that before we go back to just kind of the Trello board? Okay. Yeah, I couldn't really hear what you said. But yeah, if you could just send a message in chat if your microphone isn't working. Well.
Not now. I do.
Okay. So yeah, I will go back over to the board now. I did just want to show that quickly because I expect we'll be doing a lot of transfer learning with maybe very different dimensions of data down the line. So back to the board, we're still obviously finishing up this submission. So that's good. So that what I'm doing now is essentially, now that we have those pre-trained weights, I'm going to use them to now fine-tune the hyperparameter suites, and hopefully that will improve performance. Still keeping my fingers crossed on that. Yeah, yeah. If anyone wants to help out or keep working on that, let me know. For people already working on it, I'll message you later about like the best way to continue doing that, assuming you still have some time. So yeah, so that's kind of the main thing we're doing there. I did just get a message back from the weights and biases people. So they are going to upgrade us to a team account. So soon we'll be able to just be on one team and I'll have all of our runs synced there. So once I get that set up, I'll let you know too. Okay, so those are the main things for this kind of abstract and getting going with that. I think I already showed you a couple of the reports. Also, is anyone here really good with LaTeX and writing up like abstracts? Because I can write up most of it, but I'm actually not the best with LaTeX and putting it in paper format. So if anyone's likes doing that and is good with it, let me know.
Isaac, I probably can try to help with that. If you would have some raw abstract, I can help you to edit it. It's Serge. Hi, everyone.
Oh yeah, that would be great. Yeah, I had a couple other questions I wanted to ask you too in a second. So far I've just been preparing these reports on different kind of metro areas. Oh yeah, I'm gonna just temporarily, I'm just gonna mute everyone because I'm getting some feedback. Feel free to unmute yourself though. Okay, yeah, just for a second. So yeah, these are kind of, okay, yep, that's good. So these are kind of just the basic models. As I said, they're still not very good because we haven't incorporated the mobility data or other stuff in. You can see it's kind of fitting though, but not really understanding the various spikes. This is similar for like New York and stuff. But not bad considering actually the model is not getting all the data it needs to be getting. So that's just kind of the basic overview. We're probably only going to take a couple of these and actually show them in the abstract since it can only be 2 pages, but that's the basic idea. Let me go back to the Trello board. So yeah, with respect to the that upcoming workshop, that's pretty much it. I did want to give people a chance because, as I said, this is important. It's still kind of our first run. I know Maggie, Wendy, and some of the others have been working kind of on all the data we're going to integrate kind of phase 2 into the model. So that's good. So yeah, I think I saw Wendy, you said you finished joining the weather data, correct?
Yeah, more or less to one snapshot, but because we have so many different places, it does take a while to get all the data back.
Okay, yep, that's good. So I did want to ask why he's here. Yes, Sergey, do you think like, what do you think are the most important things from the weather side to incorporate? As I said before, we're thinking things like humidity, precipitation. Do you think any of those are like good things to incorporate?
That's something that I haven't checked yet. I will check it by the end of this week. I have heard a lot of different ideas about, weather type of influence, including UV and also other things like you mentioned. But it's still very controversial. I'll just have to, I'm trying to kind of like find the most relevant papers on this. And like I said, so we'll have it for you by the end of the week for sure. So just making a note for myself that I have to provide this for you. And I mean, if we want to use this anyways, we would have to we would have to put this somehow in the paper body where we would explain why we chose this data, why we chose this variables, how does the evidence supports the need for this variables to be in the model. So yeah, so, but basically the most important, to give you like the very basic feedback so far, and it's not final version. The most important thing, I think, is a temperature in this case, because was the whole UV thing, it might not be as important as temperature. Because if you look at Italy, it's a very sunny country, but it's also warm enough. And I think the warmer the weather is, the better the environment for the virus is. And the colder the environment is, then it has kind of like, sorry, it's the opposite. The warmer environment is, the virus is supposed to kind of like die off. But in the case of Italy, we don't see as much of that, happening. So, and some colder countries from Europe, where it's supposed to kind of like, the virus is supposed to live longer in the cold, it's not, showing that way. So, like I said, I'll get back to you with some more clear picture on this.
Okay, yep, that definitely makes sense. Do you think too, if we just put different types of weather variables into our model and it resulted in the model having a better fit, and like that would be a good case to look back at those from an epidemiological perspective, or what do you think about that?
Let me ask you a question, Isaac. So let me give an example, because like I said, it's kind of new type of analysis for me. So let me give an example what I was doing before in epi studies. Like I was running like logistic regression models. And the thing is, when you run logistic regression model, for example, you need to be very mindful about what kind of variables you put in the model, because if the variables are not relevant to your outcome cause, then they might skew and bias the whole thing. And then even though they might look the final numbers might look significant, but if you can't explain why that variable made into the model, if there's no literature or something like that backing that up, you just can't keep it in the model. So I'm not sure about this type of analysis, what we're doing here. Are these variables somehow interacting with each other while they are in the model, or they are completely sort of like separate?
So yeah, so at least the idea with deep learning, so to speak, is to take as much data as you can, and then based on the data and through the various layers, the neural network will essentially, it should learn itself which of the data is relevant for making the prediction given enough data. And then we could break it down by seeing what the model is specifically attending to and the types of features we're passing in. So the kind of thing with deep learning in particular is more you just pass in a lot of data, and then by having the model kind of pre-trained, and then of course you have a holdout test set, but then usually you're just looking to get to the best fit for that test set. And in theory, the idea at least is that the model will then learn based on the loss and everything else which kinds of features are the most important. But that's also why you want to have a good enough test set, which is of course hard to do because otherwise you can kind of bias it. But that's kind of more of the deep learning type approach as opposed to the basic logistic regression approach.
Yeah, of course. But I mean, so when you're putting different types of variables, different data, is this data kind of like influencing each other? Let's say you have a graph where we have three different lines, three different trajectories of certain variable. Are those three variables kind of affecting the way each of them works out?
Yeah, to a certain extent, yes. It depends on the exact architecture, how they're actually kind of influencing each other, but yeah, the different variables can definitely influence each other.
Got it. So, like I said, my task by the end of this week is just basically to provide you like a brief outline about each type of data, and we just need to have basic justification that it's because I think technically you can put any kind of data in the model, right? And maybe the model will learn something, but we still have to be mindful about what kind of data we're putting into this machine, because again, that's just my kind of like, I never had a chance to work with machine learning of this sort, so please forgive me if I'm saying something nonsense, but it just the way it looks and feels to me as an epi person, that it still there has to be some threshold which we need to establish, for the data to be able to be eligible to get into this model. And I think that threshold is basically just, if the data, if there is any evidence anywhere in the research that someone has used this sort of data and successfully worked with it, I think that's more than enough as of now for the COVID-19 specifically. So because there is not much finalized research yet anyways, so.
I would like to add, sorry, I don't know your name right, but you can feel free to drop by the task risk channel, because we are working on that. Basically seeing which of the risks like humidity and pollution, which are relevant to the COVID-19 spreading and the process of acquiring the COVID virus. So we have some papers on that. So just you can ask me or ask anyone in the team, and they can provide you with the papers, relevant papers for those risk factors.
Got it. All right. I see. Yeah, I will definitely, ask questions. And it would be good if we could, do you guys have any kind of like email exchange as well besides the Trello, so we can, because I don't think I have all of your
Slack.
email. Okay. Slack,
Yeah,
Slack
yeah.
is, sorry, it's even better. Yeah, sorry. I'm lost today. It's too much work, so I'm just sneaking out of work for the meeting, but that's fine. All right, so yeah, any other questions to me, Isaac? Do you have any specific?
I was also wondering, you probably worked more with kind of the basic statistical models before too. Do you think there would be like a chance to combine and like create like a hybrid model? Like maybe if we create like a deep learning model that like address some of the like, I don't know, like the actual infection rate or something, and then we could plug the number from the deep learning model into like a Seer model, so it's kind of like a hybrid of the two. Do you think that's kind of plausible?
Yeah, that's actually a good idea. I think sometimes that's what works out best, and sometimes you'd be surprised, but sometimes this simple statistics kind of like comes out with more meaningful results than some sophisticated stuff. And that's what I heard, at least. I'm not sure if it's the case every time, but we can think about this. I have worked with certain types of analysis, and I can quickly learn something if needed. Yeah, and it just all depends. Like I said, I know that you provided me with like the description of the data, but do you have any kind of like a table that contains all the data dimensions and variables and stuff like that, and kind of like a little bit more details? What kind of data, what kind of variables are those, continuous or binary or whatever? So if I could see that, it would give me better perspective on what can be done with this stuff.
Yeah, that's actually a good point. We should work on creating a concrete data dictionary, which
There's a
basically,
model, Rima.
Yeah, data dictionary. That's like, yeah, that's a good. And I think it's going to be not even one, but several, because I think for each of those data sets, there is a separate data dictionary, basically.
yeah. So yeah, actually, this is a good one for someone to pick up if someone wants to start working on this too. Yeah, data dictionary, just documenting all the fields in our data frame and yeah, the different types of variables. Yeah, that would be good, and we could add it to our wiki pages. I don't know if you've seen our wiki, but that is kind of where we're using for the documentation. So basically, all of our documentation we're adding to there. So it's not very thorough right now, but I do have this general pandemic modeling page where I describe stuff. These are our pre-training data sources where you're looking at, actually this needs to be updated, so we're looking at pre-training on different virus outbreak data. Then these are our horizontal data sources. Again, this isn't complete, but the idea would be to add a full dictionary for all these kinds of things. But yeah, that's definitely something we should look towards, working towards.
Can you please
Okay.
send me the link to this GitHub? I will look at it.
Okay, sure. Yeah, I'll do that.
Thank you.
Okay. So yeah, I think that covers most things. Does anyone have any other questions just in general? Okay. So yeah, that's good. As I said, so the primary thing until the end of tomorrow is just to try to get this finished up for the basic transfer learning. And again, this abstract isn't meant to like be like the full like authoritative like, oh, this is the best way to forecast the virus. It's just meant to kind of show and investigate like if basic transfer learning on other time series data can result in better performances. So that's why we haven't incorporated all that important kind of, I'll just call it phase 2 data, which is going to be the thing that really gets our model a good fit and in some ways is the most useful. This is kind of more of a preliminary investigation of is transfer learning useful and to what extent. But then, yeah, we're definitely going to improve with all that additional mobility data, weather data, UV data next round. So yeah, that sounds. So that's the basic approach. Again, yeah, there already have been a couple people working on this. So, but if anyone else wants to volunteer to finish up this, help finish this up, you're more than welcome to. Also, it's fine to keep working some of these other items if you have time, because those are going to be kind of the main goal moving forward. Just once this immediate thing is done. Oh yeah, access. I think everyone who needs access, at least for the moment, has access to the core code base, right? Does anyone still need access?
I think I don't have access. Maybe I didn't check it, but
To what? I think the main repository is all open source, so our core
Got
code here is all open source. What I was talking about there is I have a very large deep learning for time series forecasting library that is currently actually still private, but it's actually somewhat confusing to use if you're not used to it, and it's basically just for running kind of the core experiments right now. So I could definitely give you access to that, but as I said, it's primarily just a deep learning for time series forecasting library and isn't really that related to what we're doing unless we're actually running experiments which are using it. But yeah, I can give anyone else who wants access to that too. Okay. Any final questions, concerns, anything like that?
Actually, earlier you were saying that combining the deep learning model with the kind of like the statistical models, is it that you are feeding in some of the statistical predictions as input to the neural net, or the other way around, or just somehow combining their predictions?
Well, I mean, this is something we'd have to investigate more, but really, I think it could be done either way. So there are ways where you could take the outputs of the neural net and feed it into the statistical models. Kind of on the other side, I think since we are very data limited, there are some ways we could maybe use the statistical models to almost simulate simulate training data of a pandemic. Obviously, this wouldn't be the final data we fine-tuned on, but could improve our model fit just because training data is limited. So yeah, I think there's a lot of good stuff there we could explore.
Yep.
I kind of got the idea because I know in a couple of previous time series forecasting competitions, some of the best models have actually been hybrid deep learning statistical models. So I think that might be something to explore here too.
Yeah, I think one of the ones that came top a year or two ago was combining an RNN with exponential smoothing, if I
Yeah.
remember correctly. There was a
Yeah,
trial.
yeah, exactly. In like the M4 competition. Yeah, I think so. Yeah, I think that is a good potential area to explore here. Oh yeah, also another thing I added, it would be good to get like kind of a Bayesian confidence interval. So it's like less important if we predict exactly how many cases, but we can predict a certain confidence interval, like the cases will be in this range. So I've been looking at some Bayesian deep learning stuff and how to output those. But yeah, these are all good topics for kind of like our next phase of modeling, our phase 2 stuff. Okay. So yeah, I think these are all good directions to explore. Yeah, for now we're just primarily finishing up the health workshop submission. But yeah, we'll definitely look into that. Okay, so that's basically it. Oh, I did want to ask people, are these still good times to meet, like at 1:30 on Tuesday, Friday, or is there another preference?
It's fine with me.
Yeah, it works quite nicely for me as well.
I think.
Okay, yeah, in that case, I guess we'll keep our current schedule as always. Everything is being recorded and put up on the wiki in case people missed the meetings. So sometimes it takes me a couple days, but I do get it up there. Okay, so with that said, I think that addresses everything, unless anyone has anything really last minute. But have a good rest of your day. I'll be in touch with the people to keep working on the health workshop submission. But yeah, bye guys.
Bye.
Have a good day,
Bye.
everyone.